Hi everyone, I am Tanya Janka, and this is my amazing, incredible friend Adam Shostak. And you have Tanya and Adam on stage, so obviously we are going to talk about threat modeling. Thank you so much for coming. We're really excited to be here. So our talk is called Red Teaming AI, 50 Years of Failure, but this time for sure. And you'll get the point as we continue. So there is a disclaimer. Who here has not been disclaimed yet by RSA? Yeah, ours is the same one you've seen 100 times, so I'm going to assume it's okay to just like cruise on through this. So let's talk about what we're actually going to talk about, which is AI, and how we feel, and some of you may feel, that developers plus artificial intelligence can sometimes mean danger. Basically, the intersection of AI and software development, plus AppSec, of course, presents like awesome opportunities, amazing new innovations, et cetera, but some challenges as well. And as it becomes more integrated into software engineering, we wanted to talk about some of the risks that are going to happen. And so red teaming has not solved this problem yet. So we have been doing pen testing and red teaming for around 50 years now. That is a long time. And it is still extremely important and still extremely valuable, but it hasn't solved our problem. And so basically, like, we penetrate, then we patch. We penetrate, then we patch, right? We test it, and then we fix it later. And so this limitation is even more critical for AI systems because we're going faster than ever before. And so we wanted to talk about a more proactive approach. So our theory, because we are not biased, is that threat modeling could help reduce the risks of AI. I know that you're very shocked that we would suggest that threat modeling could help because obviously neither of us really love it a lot, and maybe write about it and talk about it all the time. But yes, so Adam, I was thinking you could explain what threat modeling was.
Absolutely. So threat modeling, really, there's a lot of complexity that people pile on to threat modeling. But threat modeling is actually very simple. It's using models to help us think about security. It's simplifying things so that we can see the forest, not the trees. And when I say threats, just for clarity, I mean potential future problems. It threatened to rain. That car threatened to run me over. And these techniques, which I'll talk about specifically in just a second and throughout this talk, can apply to the systems you produce and the systems you deploy. And I often talk about threat modeling focused on developers because the earlier we do things, the easier it is to do the earlier we threat model, the easier it is to build security in. It's going to be a theme for today's talk. It's also a theme for my work. But it applies to both the systems we produce and the systems we deploy. And I often talk about measuring twice and cutting once. And when we're working, say, in a wood shop, it's really obvious why measuring twice and cutting once helps, which is we have a stack of useless wood in the corner that we cut too short. And in software, we don't have that pile of waste, And I want to be a little cautious here, but the work that developers do without taking security into account can lead to rework, and that's expensive. And so I want one more contextual thing, a quote from Frank Lloyd Wright, the architect, who said, "You can fix it on the drawing board with an eraser or on the job site with a sledgehammer." And threat modeling is all about techniques to help us fix things on the drawing board so that we don't have to fix it on the job site. So how do we threat model? There are 4 very simple questions that we ask. They are, what are we working on? What can go wrong? What are we going to do about it? And did we do a good job? And there are lots of ways that we can answer each of these questions. For example, data flow diagrams are one way to answer the question of what are we working on. And they're so associated with threat modeling that people will sometimes call them threat modeling diagrams, or they'll call the diagram the threat model. Okay, not wrong, not sophisticated, not complete, but okay. And similarly, when we ask what can go wrong, I often talk about STRIDE. STRIDE is, for those of you who don't know it, STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, and expansion of authority. I say it a lot. But it's also totally legitimate. I often work with executives, and I don't even introduce STRIDE. I just ask them, what do you think can go wrong with this system? And then I have to reassure them, because I'm a technical expert and they're expecting that I want a technical answer. I don't. I want to know what they're worried about so that we can incorporate those problems into what are we going to do about it. Because if your execs are concerned about something and they're holding it back because they think you want a technical answer, we're engineering less effectively. And so each of these simple questions can be used with specific technical tools to drive answers, and they can be used simply as questions to drive a conversation about the things we're going to do. And spoiler alert, I think that in AI, in LLMs in particular, there's a perception that this slows you down, and so we shouldn't do it. And I'll tell you, once you develop the muscle to do this work, it speeds you up. You do less rework, you come up with fewer bad problems where you penetrate and then you need to patch at the end of the day, or worse, you have a risk management decision to make. And then you escalate it and people fight and they argue about what the true risk numbers are, all because you didn't ask what could go wrong in the beginning and let that inform what you were doing. So there's my quick introduction to threat modeling. And let me introduce myself. So hi, I'm Adam Shostak, as Tanya said. And you may know me for my work in threat modeling. I've written several books, created the Elevation of Privilege card game to help people threat model, one of the versions of the Microsoft threat modeling tool back when I worked there. I advise Arius Risk, which is a great company that helps people automate threat modeling. Also, along the way, I helped to create the CVE, which last I checked is still funded. I'm on the review board for Black Hat, and I'm a professor at the University of Washington. And I somehow also find time to run Shostak & Associates, a consulting firm where we help people threat model.
Nice. I'm wondering if one of you could do me a favor and take a picture of me and Adam at some point and send it to us on socials, because this is my third talk this week and I've had 0 photos and my boss is like, what are you doing? Plus I'll show my mom.
Here, let me come around.
Awesome.
Are we just gonna, okay.
Awesome. So I'm Tanya Janka, and I do developer relations at SumGrep. And I'm also known as SheX Purple, and thank you. I wrote 2 books, Alice and Bob Learn, Secure Coding and Application Security. I've worked in tech a long time, and I'm always telling people I'm old, because I want you to know that I am good at this and been doing it a while. I founded some things. I'm an advisor at Catalyst, a security champions coaching company, and I'm a research person, or I am a faculty member at IONS with Adam. And I admire this dude a lot. And so hopefully you're like, she seems tolerable, I'll totally put up with her because Adam's here. Now, what are we working on? So Adam and I were thinking we would form this talk around the 4 questions. Because quite frankly, we do the 4 questions all the time with clients. And so it's like, how are we gonna organize our talk? I'm like, well, I mean, we kind of have the perfect thing. So I'm gonna cover, what are we working on when we work with AI? So what are we working on? Our LLM? Oh, actually, no, Adam, this is yours.
Is this mine?
This is your slide.
Okay, this is my slide. I'll talk about this. So when we talk about what are we working on, I find one of the sources of confusion is that AI is so broad, so many things get lumped into it. And as we get more specific about how we're working with it, we create opportunities to get better understanding. So if we're building our own LLM, foreshadowing, the set of threats we worry about is different than if we're using somebody's LLM, right? We might worry about different things in training and what our training data set is, but if someone else has trained the LLM, we can only look at it and say, are their answers acceptable or even available? We can also use someone else's service, right? So we can call the APIs at OpenAI or other firms, or we can use an LLM that's integrated by someone else into their systems. And an example of this would be like Microsoft Defender Copilot, where there's an entire business value with LLMs built in. And so it's important to know, what are we working on? The other thing, which we don't know we're working on, is Shadow AI. And Shadow AI, we don't know we're working on it because it's Shadow, because we're not applying policies to it. It adds a tremendous amount of danger to our systems that is hard to assess. So as we talk about each, so when we're working on our LLM, as I said, we train and fine-tune our LLM using some data set that we want to use. And an LLM is a statistical token prediction machine. All it ever does is takes your input, feeds it into a big statistical model, and says, here's the next thing that is likely in human language or in images or whatever it is that we are working on. And the prompts drive these statistics, and it's important to understand this. We're going to come back to it as well. But when it's our LLM, we control the architecture, we control the training processes, we control the optimization, and we're making large investments in those things that allow us to customize for our specific needs. When it's someone else's LLM, we can either download it and run an open source model. And just as an aside, I don't think there are any open source models. There are open weight models, but you can't actually get at the source and build the model yourself. Or we can call their API. And the provider trains it, maybe using our data, maybe using some other customer's data. They optimize it, and maybe they update it, in which case, maybe tomorrow, the model we're calling is totally different than the model we were calling yesterday. And that makes for complicated engineering as you decide whether or not things are going well. And we can do other things integrated into our application. And when it's someone else's service, instead of integrating an AI model, we build in somebody else's service. They have a lot more control over the business value that we're offering. We rely on their API, we rely on their infrastructure. And then when it's Shadow AI, because it's unauthorized, we've got a big frowny face up there. You know what Shadow AI is, I don't have to explain it. There are so many free tools, it's hard to block. At IANS, we get this question all the time. How do I block Shadow AI? Well, you block access to Google, Amazon, your phone, right? There's just so many places, and the list was updated this morning. I don't know what was added to it, but I'm very sure that somebody else launched an AI feature.
Oh, Mac OS.
Mac
itself. Now you can't disable it.
Now you can't
You can't uninstall it.
Okay, cool. I'm glad they're using my disk space like that.
Yeah.
And with that, I'm going to hand it back to you.
Thank you. So the next question with threat modeling is, what can go wrong? Right? And this is the thing that we really want people to be creative about. This is why we need a lot of diversity with the type of people that we invite to a threat model, so we can have tons of ideas and different viewpoints, different angles, et cetera, or we won't find all the important threats. So there are a lot of different types of attacks on AI. Who here has watched 3 or more talks about AI this week? Okay, yeah, so most of you. So I might go a little faster through this slide so we can get to solving the things. So model inversion attacks, which you may have heard of this week. So an attacker extracting perhaps a patient's private medical information by querying a model. So sensitive data exposure. Data poisoning attacks, so basically putting data in during the training that's wrong so that you train it wrong. Adversarial, so adding a small unnoticeable change to fool the AI model. So imagine like bypassing security safeguards because like you've misclassified things. Model extraction attacks, so trying to steal someone's model. Backdoor attacks, so it might incorrectly identify people, or normally identify people correctly, but then imagine if there's like a little sticker on their face, oh, she's an admin now, right? That would be bad. Membership interference attacks. So this would be, for instance, if a specific data point was used, like finding out if a specific data point was used to train a model can tell you a lot of stuff. So again, more sensitive data exposure. Trojan attacks. So everyone knows the Trojan horse story. So basically executing unauthorized commands. Prompt injection, so that's what me and Adam do all day long. Oh my gosh, we were using an LLM together to work on something else, and Adam, it was like, no, I can't do that, and Adam's like, please proceed anyway, and then it just did everything that it just told me it wouldn't do, and I'm just like, oh my gosh, Adam just needs to sit near me. Side channel attacks, so like for instance, by measuring how long it takes for something to happen, you're like, oh, but it hit a bunch of guardrails. So I'm onto something, right? Like a timing attack. So all of these things that apply to apps just slightly change, and then suddenly it applies to AI. On top of this, other things than security can go wrong.
Hey,
so
Tanya, can I jump in and say one thing about all of those?
Oh, yeah.
None of those require a running system. You can find all of them with a whiteboard diagram.
Mm-hmm. Yep.
Keep going.
So we're worried about fairness. We're worried about bias. We're worried about tons of privacy violations, copyright, etc. All the traditional threats that apply to any sort of app. So Stride, kill chains, cross-site scripting, server-side request forgery, all of those things. Pick your favorite one of the OWASP top 10. I bet it applies. So on top of this, traditional attacks are working. So, actually, Adam, can you do this slide?
Sure, I can do this slide. So traditional attacks work, even though AI is magical, right? If it was really as magical as we hope, it would deal with all these attacks for us, but it doesn't. And I'm just going to be blunt. I am frustrated to see in 2025, when security concerns are so glaring, that companies are still releasing tools like MCP, and I don't want to pick on MCP in particular, but MCP came out a couple of months ago, and there are glaring problems with authorization, authentication, data management, and there are two great blog posts. You can take a picture, the slides will be available, that just outline a set of attacks that if these folks had threat modeled for 20 minutes, they would have designed MCP differently. And boy, that's just, can we please do a little bit better? Are we doing a little good?
They should have called you.
And the Magic 8 Ball. Did no one threat model MCP? And signs point to no. And so as we think about this, there's also new sorts of threats. There's a lot of really interesting analysis from nonprofits, including the Berryville Institute of Machine Learning, which is run by our colleague Gary McGraw, who you might know from his time at Cigital or Synopsys or books like, I'm blanking.
It's like a Bible, it's like this thick.
Yeah, he's got a stack of great books, which I am of course forgetting the names of because I am on stage. Sorry, Gary. There's things like MITRE Atlas. There's OWASP. OWASP has now one top 10 for LLMs, and then a second AI exchange project. Both are great forms of knowledge about what can go wrong. There's some commercial frameworks from companies including Google, Snowflakes, and Databricks. And the thing that I want to encourage you all to think about as you go back to your jobs is do not tell your developers that they need to read these 6 frameworks and pick which one they're going to use. because that is hard expert work and it will lead to inconsistency. You should pick one that works for your company as part of your company's AI secure development work and say, this is the starting point, these are the reasons it's the starting point, these are the times you might want to use something else, if you even bother with that last sentence. And when we get into the frameworks, there's lots of things that they cover. So the NIST framework, and especially the European Union's AI Act, talk about risk management, there's privacy, there's bias, and you have to decide how many of these sorts of things your internal policies need to cover, how much you're going to find via threat modeling, how much you're going to find via happy paths and safe roads, and how much you're going to leave to the end for the red team. I think in the interest of time, I'm going to skip the other points on this slide and hand it back to you.
Awesome, thanks. Okay, so what are we going to do about AI? What are we going to do about it, right? Because we need to do something about these threats that me and Adam have been talking about that probably many of you have been experiencing. So I have options. So the first option is build an AI program, so like an AI task force of how you handle AI where you work, right? So security, privacy, impact, all of those things with one team, or extend your application security program to include AI. There's a trade-off there, but whichever one you choose, you kind of got to do one of them. Everyone knows threat modeling's Adam's number one thing. Mine is secure system development lifecycle. So I'm like, Adam, obviously we need a secure AI system development lifecycle. And he said yes, he agreed. So you need training, right? So many employees, they're getting zero training on AI. And then guess what? They're not using it super efficiently. They're not getting the results they want. And also they're doing bad security decisions because we didn't give them any guidance. We need technology-specific things like guardrail scanners, specific tools to help us use AI safely. Code review and static analysis still applies, even with AI. I would never take AI code and then just put it into production. In fact, when I make training, I do bad, better, best code. And so I always just get the AI to do the bad code, and I just tell it to do the thing, and it's almost always qualifies as bad. It's great. And then I fix it. Defensive AI frameworks. We don't have one to suggest right now because there's so many and they're all changing, and we kind of want to wait until there's one that everyone's kind of drawn to before we start recommending, but there are frameworks being built right now. Different testing tools, right? Because we need to test AIs differently, just like you need a different AI security testing tools. Yep. Software composition analysis, but for AI. Like it has different dependencies and things it's calling in. How do we know where it's getting those things from? Someone explained to me this week how the AI hallucinated a bunch of dependencies, and then a malicious actor went and made those dependencies. Yeah. Monitoring, of course, for the AI. License analysis. I would like to have a list of project requirements for every project about how AI is to be handled, just like I do for web apps, APIs, serverless, etc. Obviously, threat modeling, right? AI should be part of every threat modeling conversation from now on in your organization. When we do architecture and documentation review, obviously the AI should be part of that. Like there's going to be very few systems going forward that have absolutely no AI as part of it. When we do a pen testing engagement, we want to ask them about how they are going to test that, right? Like that needs to be part of our engagement and our scope. And Adam wrote this line, using AI is fun for any of these, and it's advancing very fast, and we both agree with this sentence quite a bit. I think there's gonna be a lot of cross-functional work. So like, if we could, so who here where they work, there's an AI task force of some sort? Oh my gosh, surprisingly few hands. Well, eventually all of you are gonna have your hands up because we need that. We need that to be able to continue to compete, to continue to be effective. And so engineering, GRC, legal, compliance, all of those things, we need to make sure all of them are trained, they know what to do. Okay, so also, we're gonna need to do incident response for AI. Yeah, so we're gonna need to develop either its own team or more likely the regular incident response team is gonna get some training. We're going to need tools that detect those anomalies, which is hard. We do not have those yet. So we have detection tools for other things that are adding AI, but I mean, I need to know if my AI is being a bad boy. Implement adversarial testing in our AI models before we deploy, so like red teaming. We want to control our data and our privacy risks. So like as soon as I started using AI, I fell into this and I asked it to help me write some marketing copy, and I realized that I had put some sensitive data into the AI, and I'm like, but I'm a security professional. So if I can do it, anyone can do it, right? So protecting the training data, restricting access strictly to our AI models so no one is able to mess with it or steal it. Seriously, someone stealing your model, terrible day or year. Using federated machine learning if possible so that we can reduce the risk of like having all of our eggs in one AI basket. Oh, sorry, do you want me to go back? I'm sorry, I saw some pictures up. Sorry, I was too fast. So we're gonna need some ethics and governance. And so we're gonna need to define policies that make sense, policies that are hopefully short and concise and that make sense and are logical and applicable and not dreaming things in the sky. We're gonna need to include fairness and transparency and accountability. If you submit work that the AI wrote and you didn't read it first and it's stupid, I'm sorry, but you're stupid now, right? Like if you didn't read it and you send it in, I'm sorry, no. We're gonna need to audit our AI models for bias, for unintended behavior. This has been a big issue with many IT systems throughout. We are gonna need to be really intentional about this, or we're gonna leave huge groups of people behind, or at least a bad taste in their mouth, and we don't want that. We wanna implement, so Adam came up with this one and I love it, implementing explainability techniques. And explainability can mean like, it explains to a doctor why that's the treatment. It explains to the nurse who's going to actually do the treatment in a different way. And then it explains to the patient why they have to get this treatment. And like right now it's just like, do this. Why? 'Cause, right? Like we're gonna need to make sure that we fully understand the instructions and information that we're taking from the AI. So we're not the person that's just submitting blindly.
And just a point here that I think is super important, if you ask an AI, if you ask an LLM to explain its decision, it will make up a plausible sounding explanation. You can't simply ask them what's happening. We need to build software that looks into the models to explain the choices that they've made.
Mm-hmm. I agree. And so we need to reduce shadow AI. So shadow AI is where someone is using AI that they are not supposed to. And this could mean that they're putting sensitive data into the AI on their personal computer. It could mean that they are calling AI from within the app that they built because you wouldn't give them enough tokens. It could be a whole lot of things. And whenever something's shadow, that means security is not aware, and that's obviously absolutely terrible. Training employees about the risks, how to use it safely, ethical concerns, but also how to be awesome with AI, right? When I did my performance review at SEMGREP, we had to write self-reflections, and I remember the team was like, listen, if you get the AI to write it and it's stupid and you submit it, that's your performance review, and then you look stupid. What we'd like you to do is you answer the questions yourself, and then perhaps the AI helps you with your tone, right? Because I write very casually, so I'm like, could you make a little more formal? My boss is gonna read it and stuff. And you know what it did? It added an accomplishment that wasn't true. I was like, no, I won that award like 3 years ago. I appreciate you really like me, ChatGPT. I like you too, but please calm down, right? And then also like, did I fully answer this question? Did I miss anything? Is this a good question? Is this something appropriate to tell my boss? Like, could you rank these in order and help me prioritize them? And so they gave us a bunch of instructions of how to use it effectively. And they're like, wow, your performance review was like a pleasure to read. I'm like, thanks. Can't wait to read what the AI wrote for you. We want to monitor unauthorized API usage, and by that I mean that's just another shadow AI, right? We want to scan code. So now all the SaaS, or most of them that I'm aware of, have a set of rules specifically for finding shadow AI in your code. If you have static analysis and you're doing it, just call your vendor and be like, yo, where are those rules? How do I flip them on? Please flip them on now. And now, Adam, did we do a good job?
Did we do a good job?
Tell them why you ask this. Tell them why this question is part of it.
Sure. So this question is part of the way we threat model, and I got into a little bit of discussion, I'll say, with Martin Fowler and his team, who said, retros are part of good practice. Everyone is already doing them. Why do we need them as part of threat modeling? And my answer is threat modeling is often new. It's often a different set of things. And making time to explicitly talk about those things helps the folks we are working with and supporting work through the concerns that they have. It helps them develop muscles. It helps them develop efficiency. Asking, what do we keep doing? What do we change as we're threat modeling or as we're securing AI more broadly helps us get to more effective practices faster. So I think it's a crucial part of how we do the work. And so the one question within, did we do a good job, is, have you looked at what your staff is doing? And my answer is, your people are outrunning you today. And I say this because all of you work with smart, enthusiastic, driven people who are trying to get their jobs done more efficiently, more effectively, and it often outpaces our ability to think about the security of those systems. There's shadow AI all over the place. Most employees have not had training. Everyone we talk to is winging it. But it's worse than that, frankly. Code and data are intermingled in LLMs, and the separation of code and data is one of the fundamental tools we have in security to ensure that the code does what we want. And failures of code data separation underlie most of the famous security problems we have, things like SQL injection, cross-site scripting, stack smashing. It's not all of the problems, right? There's authorization and authentication failures, there's DDoS, there's other sorts of problems, but code data separation is huge in what we often call the injection attacks and the override attacks. And code and data are simply unseparatable in LLMs. Remember, I told you that LLMs are simply statistical token predictors. The rules that we give them are tokens that are incorporated into the thing that the LLM is going to emit. So by design, the LLM has these injection issues, and this is really fundamental. This is not a thing which is going to be solved by red teaming. This is not a thing which is going to be solved by small tweaks. And when we wrote this, when we submitted this talk, we wrote, is there a clear path to solving this? And the RSA committee politely said, you can't use the word you want on that second line there, but you can imagine what it might have been. And there really is this fundamental problem that concerns the heck out of me. And I think there's going to be lots and lots of awards for solving it. And since we submitted this talk a couple of weeks ago, a team at Google and ETH Zurich released a paper defeating prompt injections by design. I'm so excited about this work. They have a tool called Camel. It's a research prototype, but what it does is it has two LLMs. The first one simply translates your prompt into Python code. Then the Python code is run through some static analysis to check some security properties about it, and then it's run on a second LLM. So this really actually gives us a path towards solving prompt injections, which is awesome, and it more than doubles the cost of running your system. Okay, so depending on how important prompt injection is to you, or other reliability properties are to you, this may be worth having. And then the last question about, did we do a good job? A lot of times we have, if you're lucky, and the poll did not indicate that you're all here yet, but if you have an AI task force and your AI task force has written some rules about how you're going to secure AI, you get to the question of, we complied with the rules. Are we done? Possibly, yes, that's what the rules are for. And possibly, no, right? Is it good enough for your boss? Is it good enough for your customers? Is it good enough for your brand, your regulators? And it's important to get people thinking about this because the ways LLMs can go wrong are so diverse, so open-ended, that just asking this question of, did we do a good job with the LLM, with the AI in our system, can be pretty revelatory. If there's a lot of discomfort, maybe there's more work to be done. And so with that, Tanya, you want to talk about some future challenges?
Yeah, the reason that I thought you asked, did we do a good job, was kind of like, so quite often when I would do threat models with companies, they'll be like, we'll accept that risk, we'll accept that risk, we'll accept that risk, we'll accept that risk. And then I would ask, so guys, do you think we did a good job? And I look at them like my mom would look at me when I was a teenager and I came home too late. And then they'd all kind of look at the floor and I'm like, so let's talk about those mitigations again. And then we would do the whole mitigation conversation again. And then I would get them to agree to some things that were important to me. And then I'd be like, did we do a good job? Oh yeah. And then everyone would celebrate. And I was like, thanks Adam for like being like the parent in the room that's like, that's what I thought you were gonna say. But future challenges. So we have 1,000 ideas and we only had so much time. So imagine predictive analysis for anticipating AI threats and vulnerabilities, right? So imagine using machine learning, statistical modeling, historical data in order to identify threats before they even happen, right? And so threat modeling is theoretical, it's conversations, it's past experience, but imagine being able to use an AI for that. So some options like threat intelligence, risk forecasting, adversarial attack detection, trying to prevent these attacks from, so it's nice to know it's coming, what if we could stop it, right? Early detection of the model actually drifting or some sort of data poisoning, so someone attacking our AI itself. The AI model vulnerability prediction, predictive access of control, insider threat detection. These are all things that a lot of us are struggling with. And automated AI security incident response. Yeah, no more calls in the middle of the night. So there's like some emerging technologies we're excited about, and we're watching this, maybe you want to. So cyber solutions that include AI that seem to actually be doing a good job. So XDR and SOAR, threat hunting, anomaly detection, those are things that are hard to do manually. AI-generated code, but imagine focusing on more secure solutions. So imagine if by default the code that was created was very secure. I have a lot of thoughts on that. Adversarial machine learning defenses, which use AI as part of the way they're doing their thing. Software supply chain, SBOM, software composition analysis, reachability, exploitability. So actually making sure our dependencies are worth updating other than, because that's smart generally, but like there's actual risk, so it's worth doing and dying on that hill. Vulnerability fixes that don't suck and crash everything. AI resilient identity systems, because right now there's some flirting between AI and identity systems that doesn't always go so great. Okay, so other things we'd like to watch, governance and compliance automation. So give the boring stuff to the computers, we get to do the cool stuff. Shadow AI and unauthorized actions, being able to detect that is really important. Code sandboxing. This is very cool, self-healing AI systems, or code systems that use AI to self-heal when they've been attacked. Generating training data and testing data, so no longer do we have all production data is actually just in dev as well, and staging and all the other areas. They're like, oh, it's dev data. I'm like, yeah, but is it the exact same as production? They're like, well, it hasn't been updated in 6 months. I'm like, yeah, about that. Cyber deception, so using AI to trick the threat actors and waste their time. I love being annoying to threat actors. So Adam, would you like to do some concluding?
Sure, I will take us in and hopefully give a few minutes for questions as well. So we would love, you're shocked that we want you to apply what you've learned today. And next week, and we didn't know how the poll was gonna go, but go back and stand up a cross-functional AI security task force. Get the set of people in the room, including legal, compliance, engineering, marketing to talk about what it is your company and your organization should be doing to ensure that you're meeting your commitments to your customers. Over the next 3 months, think about how AI can do serious damage. What can go wrong because we are using AI? And this is threat modeling, it's some red teaming, it's frankly reading the news. The news is a great source of answers to the question of what can go wrong because your competitors are not doing this and they are embarrassing themselves, they're upsetting their customers. You can choose if you want to do those things or not, but if you don't choose, you're making an implicit choice and you're going to be surprised and in pain. Document what you understand, and I'll tell you, when I say these words, people often are like, oh God, legal won't let us write it down. I work with a lot of lawyers. They love it when you write down, we are aware of this problem and we plan to fix it by doing these things because that shows diligence when that thing blows up in your face. You weren't just like, doo, 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 doo. Oh, you were planning for it. And within the next 6 months, you should absolutely, and Tanya wants you to do this faster, I want you to do this faster, but it may require some pre-work before you can include AI problems in all new threat modeling activities. We talked about the frameworks from Berryville, from MITRE, from OWASP, some of the commercial ones. Picking one that you think people should use in your organization consistently will take time. Training them will take time. Setting up a system for helping them when they have problems applying it, when they're not sure what the words mean, how the threat might show up, how to mitigate it. All of that requires work so that when you roll out the new threat modeling requirements, it goes smoothly. And go ahead, implement these important, Tanya's talked a lot about mitigations that are available today. Implement them, put them into practice, put them into production. And then, as you're doing this on an ongoing basis, building out a threat modeling program that's going to anticipate your AI threats, building some incident response to manage issues as they arrive, putting in place budget and staff to manage each, all of these take us beyond the idea of red teaming to the ideas of engineering so that you are ready for the problems as they emerge. Last point I want to make, and this is critical, this is not a one and done. This is not, we're going to do it as a project for 3 months, we're going to clean everything up, and then it'll stay clean. This is a commitment that you need to make along with the budget for running AIs or the budget for GPUs and the power and all of that is the ongoing security investments that your customers deserve so that you can deploy AI in ways that drive business value. So with that, thank you so much for listening. Thank you for your attention. Thank you. And if you have questions, there's some microphones. Please speak into the mic so that the recording has it and we don't have to repeat your questions.
We will also, when this is done, stand outside and you can totally chat with us.
Don't tell them that.
No,
Let's
you
get
have
the
to stay
questions
here. You get nothing. Oh, and there's some stickers up here if you want some, if you miss them.
Just wanted to very briefly, you mentioned BIML, Dr. Gary McGraw's work.
Yep.
Can you tell us a little bit about your thoughts on their model and as it relates to threat modeling?
Sure. So I like the model. I like the work that BIML, the Berryville Institute, has done. And I think it is most useful as a tool for those who are training their own large language models. There's a lot of things in there that if you're not training the model, you're on the receiving end of the threat rather than the producing end. And so I think that that's the place where it shines the most. Oh, actually, one other thing. They call it an architectural risk analysis. The difference between that and a threat model is like 2%. So just read ARA to mean threat model.
Thank you, Adam, and thank you, Tanya, for the talk. I have a question on the frameworks that you actually pointed out for threat modeling. Generally we tell our threat modelers that they should just stay with the 4 questions, right? Because they can actually find more things which are not necessarily mandated in any framework. But the problem with the frameworks is, like if you take a look at MITRE, you've got 1,300 techniques over there. So how do you do this within an SDLC and actually get them going, right? Because if you try to use something simpler, then your issue is you might not have caught all the threats, because that's what people say. Like, did we do a good job? Are these all the threats, or are there more? And the other one is, all right, I'll go with something like MITRE, and that's like 10,000 threats now, so they don't even know what to do.
You can
Okay.
totally.
So the first thing I would say is I tend to use the tactics of delivery, installation, persistence, command and control as models. And so I think in Attack there are 9 of those, in Atlas there's a few fewer. And the value of the techniques and procedures is if someone says, I'm a software engineer, not a threat analyst, I don't understand what persistence means, there's a bunch of examples that they can skim through and use. So I don't know all 1,300 procedures in Attack, but I can use Attack to help me threat model. Also, Tracy Bergeron and I, Tiffany, I'm so sorry, bad at names. She's with the Center for Threat Informed Defense at MITRE. We just did a 4-part webinar on the different ways that MITRE and I use Attack within threat modeling. If you go to my blog at showstack.org/blog, you will find a link to that. I think it's currently like the 2nd or 3rd post down. The last thing I want to touch on is the question of coverage. You said they won't find everything. And a choice that we can make as we think about a threat modeling program is consistency versus breadth. And we often get people who are like, am I going to find the super ninja sorts of problems? Probably not. But we'll find the ones that we look at after the fact and say, wow, how did everyone miss that? And so I think it's very important to value getting something done and not letting the perfect or our aspirations be the enemy of improvement and good. And I want to encourage you to celebrate the good. I want to encourage you to celebrate the progress. And think about the investment that you might have to make from a corporate perspective in training versus, wow, we've made some progress. Is that enough progress for us? Does that make sense? Okay.
I want to add on slightly. So I agree 110% with Adam. Each AppSec program is different, and some of them have a lot of time and people who are willing to threat model, and then I'm going to do a lot more with them. But quite a few are like, I've never done this before, I'm kind of scared, I've heard of Adam, I even saw his book in a bookstore once, right? And so I usually start with the 4 questions with them with that, and it's like, if we could do the 4 questions on all of our apps and just have a 1-hour session to start, and we can keep up that pace consistently, like Adam said. And then from there, it's like, okay, so we got a lot of good value. Do we want to do more, or are they on to something else, right? Like, I find that a lot of AppSec programs change over time, and it's like, I try to do it based on how much I can get away with. Like, when I started pen testing, I remember asking my mentor, well, how do I know when the pen test is done? And he's like, exactly when you run out of hours. And you just do the absolute best you can in the amount of time you have. He's like, if someone gave me 6 months, he's like, Tanya, I will drone away for 6 months. No one ever does, but so you kind of have to work with the amount of time you have.
Hi, thanks for the talk, guys. So the question I have for you about threat modeling is, how do you kind of balance the two sides of AI, where like there's one side where people are like, I want AI in everything, I love AI, like this is going to improve it, and the other side that are so scared of AI. If you do threat modeling, you're going to get more scared and be like, I don't want any AI in my systems. So how do you kind of balance those two ends of the spectrum?
I haven't really run into anyone that's like, I don't want, well, okay, so I have this one friend named Darren McKee that wrote a book called Uncontrollable about how AI is going to take over the whole world. So that guy doesn't want any. But pretty much everyone else I know is like, yeah.
I don't
No?
want AI in most of my things. I don't
Actually-
need the Google summaries of things before I get to my results. Make me wait 3 seconds for it to type stuff. Excuse my language, WTF.
Oh, I thought he meant like in people that are building products, all of them want to put AI in.
I mean, both.
Sorry.
Like, I agree with you. I think the Google search thing I haven't found useful, but like, you know, I feel like there's people that just want that kind of AI in everything they do.
So I think that number one is choice. Why are you spending money producing a thing that I don't want? So give people a choice, think about the business value, and think about the question of what can go wrong, right? One of my favorite examples is lawyers using ChatGPT to write legal briefs, right? It's not suited for that. You shouldn't do it. But there's also an awesome little research tool that I make use of called Elicit, which summarizes academic papers and does a really good job. And for every fact it puts in the result, there's actually a link that works to the original academic work. And so thinking about, and when I compare those two things to your question, one of them thought about what can go wrong, what are we going to do about it, and produced a tool that I make use of when I'm doing academic style research. That makes the tool actually useful to me. And so I think rather than just being like, hey, we've got AI features, look at us, we're great. That bit, and in the case of Elicit, there's a lot more work that goes into it, but really thinking through the threats and the mitigations to deliver a business value goes back to the measure twice, cut once that I said at the beginning. Right? You figure out where the value is, you deliver that value.
I would also say if you think about, when IoT devices came out, now like my fridge is smart, my car is smart, everything's smart, and it doesn't always add extra value. I think it's really important when they're like, we want to add AI, that as part of that plan, you're like, this is how much it will cost to secure AI. And we're not going to add an extra feature, especially like a really core important feature that's very powerful, without paying for it.
Okay.
Right.
With that, the music of doom has
Yes,
started.
yes,
The
we are
stop
supposed to leave.
flag has
Thank
been
you.
flagged.
Thank you.
Tanya and I, thank you again for your time.
Thank you. Thank you.
Tanya and I,
We'll be outside.
we'll be outside. Yes, thank you.